From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Donnfelker.
And I'm kaushikgopal.
Welcome to the show.
In this episode of Learning Kotlin, I want to take a quick look at three important keywords: inline, no inline, and cross inline. If you've been working with Kotlin, there's a high likelihood that you've run into the inline keyword. You probably haven't run into the other two though, no inline and cross inline. And in this episode, we'll dive into the details of all of the three and figure out what each of these keywords mean. But before we get to that, my thanks to Microsoft for sponsoring this episode. They'd like to promote App Center. So what is App Center? We've actually talked about them in detail in previous episodes. I use them now on a daily basis as a CI service. With App Center, all I do is commit my code to GitHub and then just power on with my next feature. In the background, App Center pulls from GitHub, it runs my Gradle build, it runs my unit tests, it even runs a launch test, which is pretty amazing because then never surprised with an app crash on launch because you're checking for that. I've actually even tweaked App Center even more, and I have lint checks. Now, in certain projects where I know we have a certain number of warnings, we've all been there, no judgment, I've actually added checks to make sure that the build fails if we start to add to those warnings. So if I have a certain warning count, if I notice that any code that gets checked in bumps that warning count, I can fail the build if it crosses that. Obviously, if there are lint errors or any other such test failures, I can fail the build even then. It's really versatile. But that's not the only thing they do. As a fully modular suite of services, you can pick and choose the service that you need and connect it to the tools that you already use. They have crash reporting, analytics, push services, a test device lab of their own, and you can selectively pick just the service you want and plug it into the pipeline. Head on over to appcenter.ms. That's a pretty cool URL too. And you can sign up for their service. You know what? Just give it a shot and try it. I think you'll like it. My thanks again to Microsoft for sponsoring today's show. Definitely check out App Center for a suite of really cool development services. Okay, let's start with the main one, inline. Now, the inline keyword is actually super versatile, and there are subtle nuances that I'm not going to get to cover in this episode alone specifically. For example, inline reify types are a concept that at the time were kind of new and very interesting to me, and I'm probably going to devote another future episode just for that. But before we do that, we need to get the basics out of the way. So let's start with that. What is the inline keyword? Inline is a keyword that you apply on a function in Kotlin, so a function or a method. When you apply the inline keyword, basically the compiler takes the exact code that you have in your method or your function, it copies the whole thing and then just pastes it in the actual call side. So let's take an example. If I have a function A and I've inline function A, so I've basically added the inline keyword on top of the declaration. That's what I mean by inline. I now call function A inside my main method. So think of maybe like a static void main kind of situation. Obviously, there's no static keyword in Kotlin, but you should probably already know that by now. Whatever, I'm calling function A inside my main method, right? The code that you have inside function A will now be taken and placed directly in your main function. So it would look almost like function A never existed in the compiled down code because all of that code is taken and basically pasted directly into the main method. So that's the inline keyword. It's actually pretty simple if you think about it in terms of what it means alone. Now, before we even proceed, I want you folks to actually take a look at the compiled down version of the code because usually this is the best way to learn and confirm all of this stuff that we're learning. So don't just take my word for it. You should hit pause on this podcast if you're driving. Well, if you're driving, you should probably pull to the side of the road, pull out Android Studio and confirm this. But a question you may have is, okay, so how do I do that? How do I check the compiled down version of the code? In IntelliJ or Android Studio, write your Kotlin example, add the inline keyword, Okay, do what we have talked about, like the whole function A method, main method example thing. Go to Tools. I'm just pulling out the menu myself here. So go to Tools, Kotlin, and show Kotlin bytecode. So with the Kotlin code open, the snippet that you have with inline, switch to the bytecode view. There's this thing called a bytecode view. So switch to that once you have this option for showing Kotlin bytecode. It'll basically show you this machine code-like file. This is basically what the JVM consumes and reads. It's obviously not machine code. It's a little higher than that. It's at a higher level than machine code, but it looks very low level. But this is also not exactly super helpful for us. This isn't really going to help you understand the stuff that we're discussing. In this bytecode view, however, there's a button on the top left called decompile. That decompile button is where it's at. So hit that button and it'll open a decompiled Java file. This is what your Kotlin code sort of boils down to if you understand Java. So this is the equivalent Java that the compiler thinks you have written in Kotlin. Now, if you play around with adding and removing the inline keyword, you should very easily be able to confirm the stuff that we just talked about. If you did what I just told you and you tried the example as I mentioned, that is having a function A, then having a main method, and then at the call side, which is main method, you call function A, all of this makes sense. However, Android Studio or IntelliJ would have thrown a warning to you if you try to compile this code. The warning says expected performance impact of inlining, public function A, can be insignificant. Inlining works best for functions with a Lambda parameter. So this is the interesting part about inline, right? And this is the part that makes it a little slightly more complicated than just simply the definition of inline, which is copy the code and paste it somewhere else. Inlining a regular function is usually pointless. So after we learned that beautiful definition, I'm sorry to break it to you, but there's no point in inlining a regular function. There's almost no benefit to be gained in this case, as the JVM is really, really good at optimizing like basic method function calls, right? So if there's nothing different about it, the JVM does it pretty well. For your curiosity, what you should actually do now is, try the different variants. For example, using this decompiled view, what you should do is just maybe call a regular, like just a straight up regular function. So in your main method, you're calling function A. What does the compile down version look like? If you notice, essentially what the compile down version looks like is just calling this dot function A inside the call site, which is your main method, right? Because the function belongs to this class and main also belongs to this class. And so it just like delegates that call to the function because it belongs to the same class. This is like the most straight up regular function method call, right? Nothing different about this. Now, if you slap the inline keyword in function A and repeat this process, you'll notice that it looks like this whole function A doesn't even exist and then all that code is pasted in, right? So there is something different about it, but it's not giving you any benefit, which is basically what the compiler is complaining about. But where you'll really start to see the benefits is in one case. This is when you have Lambda parameters, as the warning rightly suggested. So in that function A, instead of passing no parameters or just like regular objects or parameters, if I send in a Lambda parameter, then that changes things just a little. Again, to be clear, anytime you pass a Lambda parameter or another function. So you can pass functions as well inside parameters. So in both of these cases, the inline keyword comes in extremely handy. So let's dive into some more specifics. This is actually much easier in code than in audio. So I'll drop a snippet in the show notes so you can take a look. You can take a quick glance after I give my explanation, and it should just be super easy to follow after. Say I have a function A again. This time, it accepts a Lambda, right? Inside my function A, I call the invoke function on this Lambda. Now, basically, Lambdas in Kotlin have this special method called invoke. And what they do is they just execute the code snippet that was passed in as a Lambda. So in my main method, the call site, I'm sending in a Lambda with like two statements. This is being sent to function A, which receives the Lambda parameter. At some point, I obviously want to use this Lambda, right? How do I do that? I do that with the invoke keyword. So on that Lambda parameter, I call invoke, and the original statements that were passed in get executed. Now, if you don't use the inline keyword here with the parameter, what does the generated Java code look like? And by generated Java, I mean, the cleaned up, decompiled, that whole shindig of going to the decompiled view, coming back, and then seeing what the cleaned up Java class looks like. I wanted to find this out myself, and this is basically how I understood the true value of inlining. You'll see that the Lambda is converted to a class called function 0. Now, function 0 is a special Kotlin function. This is important to remember because this was the thing that threw me off initially when I read books. They say it gets converted to a function, and the problem is Java has native functions as well, right? This is not the java.util function that you might think, or like if you used RxJava, then you're sort of familiar with this. This is not that. Kotlin has defined in its own package kotlin.jvm.functions. It has this package called kotlin.jvm.functions. And inside that, what you'll notice is there are a bunch of these classes called function 0, function 1, function 2, corresponding to how many input parameters that your Lambda takes in. So again, when I'm sending in my Lambda, a Lambda itself can have parameters, right? If you send no parameters, guess what's used in instead? Function 0. If you have one parameter, then function 1 is used. If you pass two parameters, function 2 is used, and so on. Now, each of these classes obviously have an invoke method because that's how you basically execute the code in your Lambda. So if you think about it, this is essentially how Kotlin has managed to implement Lambdas in Java. Even if you go back to older versions of Java where we didn't have Lambdas natively, if you use Kotlin in those versions of Java, it still works. And this is how Kotlin has managed to sort of work around by creating this class called function 0, function 1, function 2, and they call invoke on these classes, and that basically gives us the power of Lambdas in even older versions of Java. But for the purpose of understanding why the inlining is important, just keep in mind that these special functions, function 0, function 1, are used to represent the Lambdas in Java code. And now, in the function A that has this Lambda, so function A is the function that takes in the Lambda parameter, what happens when you look at the cleaned up, decompiled Java code is that this parameter gets converted into a function 0. So function A has a Lambda parameter. That Lambda parameter in Java looks like a function 0 class, right? Invoke is called on that function 0 class just as expected. All this is fine and dandy, right? So this is like basic stuff. You're not even gotten to why the inlining helps. There's just one problem now. When you look at the Java code and try to figure out how all of this is glued together, you'll realize that it can be a little costly. So let's go back to the main method. So the main method is your call side where you're going to call function A, right? And if we were in Java land, how would we pass this function 0 that we have, right? Function 0 is a new class. I would use an anonymous inner class, right? And if you've been working with Android sometimes, you know anonymous inner functions are always trouble at some point, right? So if function A takes in a Lambda parameter, and in my main method, I want to pass that Lambda parameter, how do I do it? I do it with an anonymous inner function. Now, for some reason, what if this function A inside my main method was inside a loop, and this loop was called 10 or 20 times. Every time that function A is called or invoked inside the main method, I'm creating a new object. So I'm creating a new function 0 object. This can be pretty costly if you think about it, because we're basically creating this whole new class instance. And this is exactly where the inline keyword comes in really handy and to the rescue. Now, don't change anything. Everything is the same. All you do is just slap that inline keyword into my function A, and look what happens. Basically, the code that I have inside function A is copied and pasted into my main method, if you remember. So when you look at the cleaned up version of the Java code, what you'll see is that even if you've called this 10 times, 10 new objects are not created because that code is basically plucked and then placed back inside the main method, right? This is the advantage. So in this case, instead of creating those new anonymous inner classes, function 0 as a parameter, every single iteration of that loop, what happens now is you've saved up on all of that because all of that is just basically planted directly in the main method. This is basically the main benefit. And this is also why the compiler says there's a true benefit only when you're inlining things that have parameters, Lambda parameters. So this is basically the beauty and the real power of inline. So anytime someone uses an inline for a function, in all likelihood, this is the reason why they're using it. They're doing it to save on some additional cost that comes by creating a new object. Now, you might be tempted to ask, wait a second, why didn't the creators of Kotlin just always resort to doing this, right? I mean, if this is performant and this is so great, why not just always apply the inline keyword? Why do I have to selectively know and add to my cognitive load while programming to add this inline and not add this inline if I'm using a Lambda parameter? You may think like, well, if there's a Lambda parameter, why don't you automatically always inline the function? Because that's what I thought. The problem is, it turns out there are certain cases where you don't want it to be inlined. Let's talk about those cases. When you inline a function, what happens is you basically lose access to private members or methods of your enclosing class. So it's very similar, and we've talked about this in previous episodes too, right? It's very similar to the whole anonymous inner class situation. If that anonymous inner class was made static, which is typically the way to avoid memory leaks, if you remember from the Java episode days, you save up on that. But the disadvantage is you lose access to the members of the class, right? So anything inside that inner class, if it's an anonymous inner class, then you still have access. But if you make it a static anonymous inner class, you lose access to the private members of that class, the parent class. So say if I had my class helloworld.kt, a Kotlin class, right? Inside I have my main function, and then I have the function A inlined. Function A won't have access to any of the private members or methods of the hello world KT class. Now, when you don't necessarily need access to the member variables inside your Lambda, then inlining is perfect. Then you don't have any problem, right? That's a great case. If I don't need access, whatever, I'll just inline it. But if you do, then maybe inlining everything doesn't make sense, right? Now, there's a small aside. You can actually work around, even if you inline your function, you can work around this by doing certain things. You'll have to make sure that the member is no longer private. And if you add this annotation called the PublishedApi, I'll add a link to the show notes so you can have a look at this. But basically, there are ways to work around it. But I'll be honest, as an Android developer, I don't think this would ever be something you want, right? If you truly need access to your member variables, then just don't inline it. And if you don't, well, inline it. So that's one great reason not to inline functions always. There's also another really important reason. Let's again take our example. If I have a function A and I add the return statement inside function A. So let's talk about it, right? In my main function, I call function A. In function A, I'm doing something. I'm checking to see a condition, right? Like if some condition is not satisfied, I want to return. I don't want to continue executing function A. So I innocently throw the return keyword inside function A. What will happen is if your function is inlined, not only will you return or exit from the function A, but you'll also return or exit from the main method. This can be a problem or this can be what you want, right? But it's extremely important to understand this. So I'll say it again. If I return from function A, which is inlined, I also return from the caller function, that is like the main method here. And this whole thing is basically called a non-local control flow. This can be a good thing sometimes, but it may not be what you always want. So if you don't want this, again, you cannot inline the function, right? And also, by the way, if you don't have an inline keyword on the function and you just call return in function A, it only exits from function A. It doesn't exit from the main method as well. This is really, really important. And this is in my opinion, a very important reason as to why we don't always want to like slap an inline into a function. So definitely keep that in mind. Depending on the behavior you want, you may or may not want the inline keyword. Okay, so that's a lot of theory about inline. Let's talk about the other two keywords that I mentioned. There's no inline. This one is actually pretty easy because it's exactly as the name suggests. By saying no inline, basically you're saying don't make this thing inline. It's pretty obvious. So say I have my function A again, and it takes in two Lambda parameters, right? So I have a Lambda parameter 1, Lambda parameter 2 in my function A. If I add the inline keyword to the function, remember, when I add the inline keyword, it's added at the function declaration level. If you remember, that's what I said initially. You don't add it against each parameter. But what if I wanted just the second Lambda to be inlined? I don't want the first Lambda that comes in to be inlined, but I add a new Lambda parameter and I want only this thing to be inlined. This is kind of problematic because if you're applying the inline keyword at the function level, how do I selectively choose what gets inline and what doesn't get inlined with my Lambda parameters? Well, no inline to the rescue. So if I have function A and I have the inline keyword applied across function A, and I have two Lambda parameters, Lambda parameter 1, Lambda parameter 2, I want Lambda parameter 2 to be inlined. Well, because we have the inline keyword, that automatically applies. What I can do now is I can add the no inline keyword on Lambda parameter 1. And automatically, Kotlin understands that when this invoke function is being called on each Lambda, if it's Lambda parameter 1 and it has the no inline keyword, then it knows that no, I shouldn't be inlining this. Instead, I should be like delegating that call, right? So it's pretty simple. If you don't want something to be inlined in a function that has the inline keyword, apply the no inline. There's also this last keyword that we talked about called Crossinline. And I recently ran into this from another blog post, and I'll make sure to add links in the show notes to like really good resources. A friend of the show, Matt Logan, also wrote a really good post on the inline keyword. So I'll add all of that in the show notes. So make sure you have a look at this show notes. It's going to be chock full of interesting stuff. Let's talk about cross-inline. Well, one of the behaviors that I mentioned initially with inline lambdas is the non-local control flow, right? So this is that if you return from function A, it also returns from the main method. What if I don't want that? What if I feel actually, just like we have the no inline, I don't want to apply this behavior to this lambda. Is there a way I can sort of just apply that behavior? Is there a way I can avoid that behavior, the non-local control flow behavior with a function? Well, there is, and that's what cross-inline helps with. So I want to define in function A the behavior that this inline lambda should not be allowed a non-local control flow. So basically I'm saying inside this specific lambda parameter, if I say return, don't return from the main method, only return from this lambda. Can I do that? Well, you totally could do that. And all you have to do is just apply the cross-inline keyword. So if you see this no inline and cross-inline are very related in that you apply them selectively to your lambda parameters. And when you apply them to your lambda parameters, they switch the flow just for that lambda parameter. So just to recap, no inline basically means do not inline this lambda parameter. Cross-inline basically means do not apply the non-local control flow. So returning from this parameter means only return from this parameter. Don't return also from my main method. That's it for these three keywords. Quite honestly, with all of these three keywords, with the inline is much more prevalent, and you'll probably run into a case where you need inline more often than not. But with the other two, with cross-inline and no inline, you're going to be wanting these behaviors to actually use them. Like almost 90% of the time, you probably won't need these, but you'll specifically need to be able to do each of these things. And if you listen to this episode now, you know that this is in your arsenal. So you don't necessarily have to like always remember this. My point is, these are so specific behaviors that you would run into specifically that you want. And when you want, you would know that these exist. So you can just look back and see what the keywords are. So there's a very high likelihood that you probably won't use this on a daily basis. So if you land up requiring the specific requirement, now you know. That's it, folks. Hope you enjoyed this episode. 3 keywords: inline, Noinline, Crossinline. Keep learning Kotlin, and I'll catch you in the next episode. Before I wind the show down, I want to thank Microsoft again for sponsoring today's show. They want to promote AppCenter. AppCenter is a continuous integration, delivery, and feedback service for your Android apps. Check them out if you're looking for a CI solution or a UI testing solution. Head on over to their nifty URL, appcenter.ms, and spend less time managing your app lifecycle and more time coding, because in the end, that makes all of us happy. Thanks again for sponsoring today's show, Microsoft. That's it for the show, folks. Fragmented is hosted by donnfelker and me, kaushikgopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from Weightless Recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.